Good morning, everybody, and welcome to our webinar. We're very excited to present to you this morning a bit more detail about our LinkIt ONE development platform. My name is Phil Handschin, and I'm working for MediaTek Labs, and I'm based here in the UK. So what are we going to cover today? First, I will very briefly talk about MediaTek Labs, what we're all about. And then I will go straight into the LinkIt ONE hardware development kit. And after that, I will talk about the software development kit that goes along with it. And I will show you some code examples. And then I will show you the MediaTek Cloud Sandbox, which is a free-to-use cloud solution to store your data. And at the end, I will show you two exciting products we also feature to other hardware development kits, and in the end I'm open for questions. Right, so let's get started with the introduction to MediaTek Labs. So what is MediaTek Labs? As you might know, MediaTek is a big fabless company and is a very strong manufacturer of system on chips. So MediaTek Labs is the development program from MediaTek, and we do that with different things. So we create hardware development kits, as you can see on the top right. So the LinkIt ONE is one of our hardware development kits. Then we create software development kits that go alongside with them, and everything is available through our labs.mediatek.com website. Where you can find technical documentation. We have also a solution catalog where people upload their individual solutions. And we have a newsletter that goes out every month where you can find out where we attend the next events we are attending, or new hardware development kits that come available, or new releases of our software. So it's all in the newsletter. But then we also have a forum, a very active one, with like 1,000 developers all over the world, regularly kind of starting discussions about issues they're having with the board or which components they should use. So it's well worth checking out our forum, especially if you get stuck or if you have any questions, because technical consultants like me all over the world are monitoring this forum on a daily basis. So if you get stuck, we're here to help, and so you never get stuck. Right. So let's talk about the LinkIt ONE hardware development kit. So how did it come about? As I mentioned before, MediaTek is very strong at creating system on chips. So we created the world's smallest system on chip for wearables. It's the Aster chip. Internally, we call it also MT2502. So we took that system on chip, and we also took two companion chipsets, one for Wi-Fi and Bluetooth, and the other one for GPS. And with the help of Seed Studios, we created the LinkIt ONE hardware development kit. After we created this hardware development kit, we realized that we needed to expose all the functionality we put on the board. So we created an operating system and exposed the functionality through rich APIs. And after that, we created also a plugin for Arduino. So it is very easy for developers to implement their project through Arduino, or even port their project onto our board if they already used Arduino before. So this is the board, as you see from the front. You might recognize that it's very similar to an Arduino Uno in terms of the pin layout, which makes it compatible to other Arduino shields. So if you already have shields, it will be compatible to it. But let's have a look at the individual components. So at the top, you have the GPIOs. In total, you have 16 digital input-output pins. At the bottom right, you see the analog ones and also some extra GPIOs. And then you have the power output at the bottom left. So very similar to other Arduino boards. Then at the left you have at the right you have an SPI port. And then you have the Grove connectors. These connectors are a specific system from Seed Studios, which makes it very easy to connect sensors to the board. They have dozens of different ones like temperature, humidity, pressure. They even have displays. And all you need to do is basically connect them directly to these Grove connectors and include the class files you get with them, and off you go. So it's kind of advanced Lego. On the left, we see the headphone jack. There you can use it for play audio files, or you can also use it to connect a headset to make phone calls or to receive phone calls. The USB jack is for uploading your sketches to the board and also to powering the board or charging the battery, where you put into the battery jack. You have a reset button, which comes in quite handy when you develop your projects. Then you have the ST-SPI switch. There you can choose what you want to use, the SD card or the SPI port. At the bottom there you see the mass storage normal mode switch. This is when you want to access the flash memory directly from your computer. You can switch it to mass storage mode and switch it back to URT mode if you want to just upload your sketch. It's also important to check this switch position when you update the firmware, because it has to be in mass storage mode. And then the switch right next to it is to choose your power source. You could either choose USB or the battery. So here it's the back view with the metal shield removed, so you can see all the chipsets. At the left side we have the connectors for the different antennas, and here you see a picture of all the antennas. So at the top one we have the GNSS antenna, which means it can support GPS, GLONASS and Beidou. At the moment we connected the GPS and GLONASS antenna, which is included in the hardware development kit. So when you buy the LinkIt ONE, you'll get all these antennas as well. The middle one is the Wi-Fi and Bluetooth antenna, and then at the bottom we have the GSM antenna. Here you see the compact SIM card holder and also the SD card slot. We support SD cards up to 32 gigabytes. And these are now the different chips we're using. So at the top you see our GNSS chip, the MT3332. It supports GPS, GLONASS and Beidou, so all the satellite systems around the world. In the middle there you see our Wi-Fi chip, which handles Bluetooth as well. And then the main processor, the MT2502, which handles GSM. So a bit of specifications of the hardware. The processor itself is an ARM7 processor with a clock frequency of 260 megahertz. We have 16 megabyte of flash memory on the board and 4 megabyte of RAM. And as I mentioned before, the SD card we support up to 32 gigabytes. We have 16 digital input-output pins, 3 analog ones, and we have 2 sets of pulse width modulation. We have external interrupt pins, 2 of them, D2 and D3, but you could see that as well on our spec sheets you could download on the website. We have an I2C, we support SPI and URT, and more importantly, we have a GSM and GPRS support. So there's data connectivity available through 2G network. Then we have Bluetooth, both modes like EDR and BLE. We have Wi-Fi, and as mentioned before, GNSS, so GPS, GLONASS and Beidou. So that's the sheet I was talking about. This is the pin in out diagram, which is available on our website. Many more technical documents are available on our website, so please don't hesitate to head over there, have a browse through and see all the things we offer. These are some sensors. As I mentioned before, there's this growth system developed by Seed Studio, which makes it very easy to connect sensors. So there's a starter kit for the LinkIt ONE we recommend. It has already many sensors inside, so temperature and humidity, sound, UV, barometer, light, and many more. And as I said, it's very easy to use them, as you just have to plug them into the growth connectors on the board, and off you go. There are many example codes as well on the Seed Studio website and on our website as well to make them work. So let's talk about the software development kit that goes alongside. We realized that a lot of developers are using Arduino because it's very easy to use. So we created a plugin for Arduino so that you can use the LinkIt ONE with Arduino. How do you set it up? The setup is a very simple process, and it should not take you longer than 5 minutes. So first, you download the correct Arduino version. At the moment, we support 1.5.7, but soon we will support as well like 1.6.4. You register with Labs if you're not already registered, and then you download our SDK. The SDK is a simple Windows installer, although we support Mac as well, so you can download Mac SDK. The only thing you have to do before you can run it, you have to specify where you installed Arduino during the setup. But that's the only thing you have to do. After that, it does everything automatically. So there's no long installation process of installing drivers, etc. Once you installed it, you will find the LinkIt ONE board on the boards. So there will be a separate entry, and you will also have like lots more sample examples in your Arduino environment. So it's very easy to get you started. So you create your sketch. Maybe you use the Blink one, excuse me, to test if the installation is successful. You choose the LinkIt ONE board from your menu, and you upload it to the board, and hopefully it will blink or do whatever you want it to do. So the features, we support all the core Arduino features, so nothing less, but we added a lot of functionality because we have a lot of additional chips that makes the board so great. So we have the GSM module, which gives you access to sending and receiving text messages and creating and receiving phone calls. We have GPRS, which gives you a TCP and UDP socket functionality. The same goes for Wi-Fi. With Bluetooth, we support serial port profile and GATT. Then GPS, we have the NMEA format. I will come to that in a bit with the code example to explain that a bit more. Audio, we support various different formats, so you can play back your audio. And the SD card, we support FAT32 as a file format. So let's have a look at some code examples. All our classes are prefixed with L, just to make them more recognizable. And our whole aim was to make it as easy as possible to use our libraries and to use the extra functionality we put on the board. So we, for example, for the sending an SMS, first of all, we have to check if the board is ready to send SMS. So we do that by calling lsms.ready. This will give you spec true or false, depending if it's ready or not. And if it's not ready, we wait for a 10th of a second and check again until we are ready. The next thing to do is to start your SMS. So we call lsms.begin SMS and specify the number we want to send the text message to. And then we use lsms.print to specify the message we want to send out. And to finish it off and send it, it's lsms.endSMS. This again will give us back true or false, depending if the SMS was sent successfully. So as you can see, in about 4 lines of code, you can send text messages. So it's very easy to use without any AT commands or configuring anything. The other thing is, like, to receive text messages is as easy as that as well. The command would be lsms.available, and you can check if a new SMS is available. You can read out the message it came from, and the message itself. Next thing we already support on board is a GPS. Because a GPS can be quite power consuming, by default it is switched off. So if you want to start using it, you have to switch it on first. And you do that by calling lgps.poweron. At any stage you can switch it off again by calling lgps power off. So if you just want to get a fix, like on a daily basis, you just want to know where the device is, you just quickly switch it on, wait till you have a position, and then you switch it off again. Next thing, to read out the location, you get like these NMEA strings. So what you have to do is you call lgps and then .getData, and you pass on a structure, the info. And in that info structure, you get like different NMEA strings. So these NMEA strings are basically comma-separated strings with different kind of information. So for example, this GPGGA has, if you have a fixture, if you have a fixed location, the longitude, the latitude, the how many satellites you currently view, and like how accurate the signal is. You get different strings where you can find information like the altitude or the speed over ground or the direction you're traveling to. So there's a wealth of information. The only thing you have to do is to request the correct string and then parse it. So it's a comma separated string, so it's very easy and straightforward to do that. The other thing it's useful to know is that obviously with GPS you get very accurate excuse me, timestamps. So if your application or if your project needs a very accurate timestamp, you can request that from your GPS and get the timestamp and then set the local time. Right. So the next example is audio. Again, very easy to use. First, you have to initialize it by laudio begin, and then you can call laudio play file. You have to select which storage you're using. So if you use the flash storage, the onboard storage, or if you use the SD card, and then you have to select you have to configure the file name you want to play back. You then also can set the volume level from 0 to 6. So 6 is the highest. And you wait as long as it takes to play the file, and then you stop the playback. Again, in a few lines of code, you achieved like music playback. GPRS. This is a more complex example, but I think it's worth mentioning because it's still very easy to use to get your data connections wherever you are in the world. So first we have to attach the board to the GPRS network. We do that by calling lgprs.attachGPRS. This again will give us back true or false depending if the board can see a 2G network and get a connection to it. Once we successfully connected to the GPRS network, we have to create an LGPRS client. With this client, we then connect to the server and the port we want to. So in this case, we connect to a web server. So we use the IP address or the web address of the server and use the port 80, as this is the normal HTTP port. And this client then can create GET request, POST request, whatever HTTP request you want to do. but it doesn't necessarily have to be HTTPH. So you can create. It's just a client, so you can connect to any server you like. Once you connect it to the server, you then can call client.available, which will give you back true or false if there is a response waiting. If there is a response waiting, you can then read out the response by client.read until no more data is available. So again, there's slightly more to it, but this gives you a very easy access to the internet wherever you are in the world. So you just get a local SIM card, put it inside, and you have immediately an internet connection. Talking of internet connection, let's talk about the MediaTek Cloud Sandbox, which is our cloud storage. So it's a relatively new solution that MediaTek offers to developers. It's completely free to use, but it's only for, because it's a sandbox, it's only for development purposes. But what can it do? It has RESTful APIs to store and retrieve data. We have a lot of visualization tools, so you can visualize your data, different data types like floats, GPS locations, states of switches, yeah, whatever you need. There's a visualization tool for that. We also support firmware updates over the air, so you can flash your boards directly from our cloud solution. We have data monitoring, so you can set like parameters, and if they are reached, so if you say like, oh, I want to monitor temperature in a room, and the temperature goes over a certain threshold, you can configure it to be informed by email or by Google Cloud messaging to your Android application. So you can control the whole Cloud Sandbox through the web portal, but also through a mobile Android app we offer for free. Besides like visualization of data you send to the cloud, you can also control devices remotely. So you can switch on a light, or you can change a color, or you can control a servo, whatever you need. Like, it's a two-way connection. As you can see, we have different visualization types. So controllers to switch stuff on or to set stuff, then display, or hybrids, which are mixed. So it's a controller and a display in one. Some other examples are GPS position, as you can see on the top right there. Then there's the color switch for like maybe a smart light, so you can switch it to red or to blue. And then at the bottom you see the temperature over time, so that's a float value. But there are many more. The very clever things we implemented is API hints. So once you created your device in the Cloud Sandbox, so you have your temperature channel, you have your humidity channel, data channel. Sometimes it can get confusing, which unique ID you need to use, which authentication you need to use to talk to that data channel. Well, we made it very easy with our API hints. Once you created your data channels, you can just go to the data channel and click on API hint, and we will provide you the whole source code needed to upload data to that data point. So as you can see there on the screenshot, we have it for different environments, so for Arduino, but also for Telnet, jQuery, and Angular. And for both for uploading data points and also for retrieving data points. So you basically, you log into the MediaTek Cloud Sandbox, you create your data channels, and you copy the code, and within like 10-15 minutes, you already can make your device like internet enabled. So other HDKs. One we offer, which has less functionality, is the LinkIt Connect 7681. This currently retails for about $20, and it's a Wi-Fi development board. So it is a system on a chip that supports Wi-Fi. It has a TCP/IP stack. It has 5 GPIOs. It's also compatible with the Cloud Sandbox. So you can directly integrate it with Cloud Sandbox without writing a line of code for the board itself. So it's very easy to use again, and you program it with C, and you can download the SDK for free again, like on our portal. So it's a very simple Wi-Fi board. The other thing, a very exciting board we just released is the LinkIt Assist 2502. It basically has the same functionality than the LinkIt ONE we just talked about, but it is half the size. It is based on modules instead of separate chips. The antennas are integrated already on the board as well, and it has a capacitive touchscreen on top. It also has a speaker and a microphone on the board already. So it's a very professional kit. We also released a new SDK for this, which is compatible with Eclipse and is C-based. So it allows you to access the hardware in much more depth. And yeah, so it's not compatible with Arduino. It is purely on the Eclipse. And you also get like more libraries for this board, especially like the ones for the graphical output, and also the handling the touches on the screen to kind of handle those. Yeah, so what are the next steps? Best thing to do is like join labs, download the software development kit, or just have a look around. There are like lots of videos, lots of documentations. Yeah, and give us some feedback as well. Join the forum, ask some questions. We're very happy to help. But for now, like, I'm happy to answer some questions. So if anyone has some questions, I'm happy to answer them now. No, I see like someone has a question. Right, the question is, does the MT2502 support only Arduino platform? No, we support like more platforms. As I just mentioned, for example, the LinkIt Assist 2502 is based on the MT2502 as well, and the SDK is basically a C SDK which plugs into Eclipse, which gives you much more access to the hardware itself and to the performance of the chip. This SDK also works with the LinkIt ONE board. But before you can use it, you would need to update the firmware to the latest firmware. Right, so the other question is if you can run Linux on the board. Unfortunately, not. The operating system is a real-time operating system. We created our own based on the Nucleus operating system. So currently, there's no way of running Linux on this board. However, we're continually adding to our, we want to add more and more boards, and we hear a lot of feedback from developers all around the world that they want to have a board that you can run Linux on it. So we take these comments on board, and hopefully we can add a board soon where you can run Linux on it. So if nobody else has a question, I thank you very much for your time this morning, and I hope you enjoy using our LinkIt ONE board or any other boards. Thank you very much. Bye-bye.